This is Michaela Coco. Planetary Discoveries from 1995 to 2017. It's mostly about NASA, but it includes a few collaborations between other types of space exploration. A few relevant terms would be the Kuiper Belt, which is a disc-shaped region of small icy bodies right around Jupiter in our solar system. And then a light year, the distance it travels through empty space in 1 year. It's approximately 9.5 times 10 to the 12th kilometers. And then a main sequence star, it's just any star that is fusing hydrogen in its core and has a stable balance of outward pressure from core nuclear fusion and gravitational forces pushing outward. And then of course a planet, which is any object that is orbiting a star, is mostly spherical and is large enough to clear all matter from its orbital zone. And then we have a red dwarf, which is a small and relatively cool star in the main sequence. And then we have a picture of the Milky Way galaxy from left to right that includes every single solar system in the Milky Way, including ours. The first true discovery of an exoplanet was 51 Pegasi b. It was found in 1995. It was the planet that led astronomers to believe that Earth-like planets could be found somewhere else in the universe, meaning there could be a second Earth. It's approximately half the size of Jupiter, and it began what is loosely referred to as the classical period of planet hunting. This is an artist rendition of 51 Pegasi b. It's not an actual photo. The next thing to be found was pretty soon after, in 1996. It was 70 Virginis and 47 Ursae Majoris. 70 Virginis has a 116-day orbit, and 47 Ursae Majoris has a 2.5-year orbit. The next major discovery was the Kepler mission. It began on March 6, 2009. It was the first mission launched to find a second Earth. It discovered an Earth-sized rocky planet during its first 10-day trial run, and that planet was called Kepler 10b. That is a photo of the Kepler telescope. The Kepler mission between 2009 and 2013, when its mission ended, it discovered 4,496 candidate exoplanets. And of that 4,496 candidates, 2,337 were actually verified. 30 of that 2,337 were verified as actual exoplanets in the Goldilocks zone. And then in 2013, the original Kepler mission came to an end when 2 reaction wheels failed. It was found in 2009 and was actually verified in 2011. It's called Kepler 22b. It orbits a star similar to Earth's sun, almost 2.5 times the size of Earth, 600 light years away, and has a 290-day orbit. Kepler 69c, found in 2013, 70% larger than Earth, and 242-day orbit, 80% solar energy received compared to Earth. It's 2,700 light years away in the Cygnus constellation. Kepler 62f, also found in 2013, is called a super-Earth. It's 40% larger than Earth. It has a 260-day orbit. It is 1,200 light years away in the Lyra constellation. This is an artist rendition of all the super-Earths. Kepler 186f, found in 2014, is 500 light years away from Earth and is about 10% larger. Very probable that it is a watery planet, which is a very good candidate for a second Earth. It has a 130-day orbit, and it orbits a red dwarf, which means it only gets a third of the energy that we do. The K2 mission began on May 2014. It discovered 515 possible exoplanets and verified 175 of those. Kepler 452b was found in 2015. It's in the Goldilocks zone and is approximately 1.5 times the size of Earth. It has a very good probability of being rocky and is most similar than any other known today. This is an artist rendition of the universe, and the little white circle is the only area that we've discovered. The next one found was not by the Kepler missions. It was found by the European Southern Observatory in Chile. It's called Gliese 667c. It's found in 2011. It's 4.5 times the size of Earth and closely orbits a red dwarf. It only has a 28-day orbit. HD 219134b was found in 2015. It is the findings of a collaboration between NASA's Spitzer Space Telescope and Italy's Galileo National Telescope. It is the closest known rocky planet, being only 21 light years away. Epsilon Eridani. It was found in 2017 by the SOFIA, which is a stratospheric observatory for infrared astronomy. It is a nearby planetary system extremely similar to our own solar system. It's called EPS-ARI for short, and it is the closest system around a star that resembles Earth's sun in its early stages, which means it gives us an insight into how our solar system itself was formed. It has a debris disk very similar to our asteroid or Kuiper belt, and it helped prove the theory that the largest planet will almost always be closely situated to a debris belt, much like Jupiter. And then the next thing found was also in 2017. It was the Eridania Sea Basin on Mars. It is an ancient seafloor from hydrothermal deposits. It leads to clues about early life on Earth, and it is 530 miles wide. It was observed by NASA's Mars Reconnaissance Orbiter, and it was probably home to a sea about 3.7 billion years ago. And these are my sources.